Chapter 8, Part 2 is all about residuals and r squared. So the first thing we'll talk about is estimating slope. Now that we have interpreted slope and we know what the slope means, we can discuss appropriate estimations of slopes for given scenarios. So sometimes the data may not be provided, but even if we don't have that exact data, if we understand what the slope means, we can make an educated guess regarding that slope. So our first example here, if you were to create a regression model for predicting the weight of a car in pounds from its length, is the slope most likely to be 3, 30, 300, or 3,000? So we are predicting the weight of a car, which means the weight is our y variable from its length. Now we know that the slope says for every additional x. So what I like to do is kind of write this out. So for every additional foot of length, the weight will increase by an average of blank. So as I increase my cars by a foot, right? So I have a 5-foot car versus a 6-foot car versus a 7-foot car. What do I think the difference of those weights will be in pounds? Do I think that an extra foot of car is going to be 3 pounds? No, I think this is definitely a little bit too small. 3,000 pounds is far too large. And again, I'm thinking that 30 is still a little bit too small, so my answer should be 300. Go ahead and try example 2. So in example 2, we were looking at circumference of a tree trunk in inches, using that to predict the height of a pine tree in feet. So I started again by writing out our scenario for slope. So I said for every additional inch of circumference, so that's my x variable, the height of the tree will increase by an average of. So as I make these tree branches wider in circumference, what do I think is going to happen to that tree? Well, I think 0.1 is a little too small. Adding on an inch in circumference should not make my tree grow by 100 feet. That's way too large. Again, I'm thinking 10 or 1, probably my two options here, kind of narrowing it down. For every additional inch in that tree, I'm guessing that it should grow by 1 foot in height. Growing by 10 feet in height is a little bit too big again. My recommendation for these problems is to start with thinking about your variables. Always write out your scenario for slope, and then go through and kind of cross off the ones that you know are definitely false. You'll usually be left with 2 options, and then from there you just kind of have to reason through which of those options is best. In our next section here, we're going to start talking about residuals again. So remember that the residuals are the distance that your data point fell from that line of best fit. So if we had, I'm going to draw just a quick little scatter plot over here, and I had my line of best fit going right there. The residual would be the distance each data point is from that line of best fit. So each of these little distances is your residual. Okay, so the linear model assumes that the relationship between the 2 variables is a perfect straight line. We know that this isn't the case, right? Even in this quick little example, all of my data points were not on that straight line. So what the residuals do is they help us find the parts of the data that has not been modeled. So when we're searching for residuals, we're going to use this little formula here. It says to find a residual, you are going to take your actual data, so this is what actually happened, and you are going to subtract what the model predicts. So this is our prediction. Okay, in symbols, for residuals, we will use E. We cannot use a lowercase r here, which unfortunately we think would make sense, but I can't use an R because R is for our correlation coefficient, so they pick an E. The actual data is coming from an actual data point on our scatter plot, and so that is going to be our Y. And then the prediction coming from our model is our Y hat. This formula is not given to you on your formula sheet, so this is definitely something that you want to memorize. On the next page, we'll go through a few examples using this residual. Our example here says a company found a moderately strong relationship, R is negative 0.59, between the length of their employees' commute to work and their overall job satisfaction, which was rated on a scale from 1 to 10, where 10 was very satisfied. Commutes had an average length of 24 minutes with a standard deviation of 4.5 minutes. Job satisfaction had an average rating of 7.6 with a standard deviation of 2. The first thing that we want to do is write an equation of the model that can predict job satisfaction based on length of commute. So this means that my commute times are my x variable, job satisfaction is my y variable. Now I'm noticing here that they're giving me averages and standard deviations, so this is where we're going to use those two formulas that we talked about in our last lesson. Remember that your slope formula says to take your R, your correlation coefficient, multiply by SY over SX, those are the two standard deviations, and your y-intercept says to take the average y minus your slope times the average x's. Since this part here is review, why don't you go ahead and pause your video again to try this problem and then play once you have it written down to check your answers. Here is my answer for part A. Again, to walk you through this process quickly, I started with writing out the variables. Commute time was our x and job satisfaction was our y. Start with finding your slope formula, so that's plugging into this guy up here. Once you have your slope, then you can plug it into your y-intercept formula, and then finally writing everything back in context of your problem. So make sure you have your two variables listed. Okay, part B says that Jay has a 55-minute commute and gave a rating of 6 for his job satisfaction. We want to calculate his residual. So Jay's actual data value, so I'm going to put Jay's actual value here. His actual x, his commute time, was 55, and he gave a job satisfaction rating of 6. Now, we said that the formula for residual was to take your actual y and subtract your y hat. At this point, we know his actual rating was 6. That's this y variable here. The only thing we don't know so far is our y hat, which is our prediction. But once I have that formula, or that equation for my line of best fit, I could calculate his predicted y value. To find Jay's predicted y value, or his predicted job satisfaction, I'm going to plug in his commute time, which was the 55 minutes. Okay, plugging this in. So I noticed when I plugged that in, I got 55.7, which was way too high for a job satisfaction. So I went back and checked my work here. It looks like I have this y-intercept incorrect. Must have plugged it into my calculator wrong. This should be 13.84. So I'm going to change that. Sorry if you were second guessing yourself there. Okay, let's plug that rating back in here. So I'm going to do negative 0.26. At that point, we get a predicted value of negative 0.46. So the last thing that I want to do is actually answer this question and calculate his residual. To find that residual, I'm going to take his actual Y value, so his actual job satisfaction, which was 6, and subtract his predicted, which was negative 0.46. This should give me 6.46. Okay, part C says it takes Bree 20 minutes to get to work. She claims that her residual was negative 2. What rating did Bree give for job satisfaction? So at this point, we know that her residual, which is our E, that is negative 2. And she told us that it took her 20 minutes to get to work. 20 minutes to get to work would be our X value because that was our commute time. So if I'm thinking about this residual here, I'm trying to find, I'm going to write my little equation again. I'm trying to find what rating Bree actually gave for her job satisfaction, which is our Y. They give me E, but again, I don't have a Y hat, so I can find that Y hat by, again, plugging in 20. So I'm going to plug in 20 minutes now for our X. I got 8.64. Now plugging into my residual equation, the residual is negative 2. This time I'm looking for her Y value. So I have to do a little bit of algebra here. I'm going to add over the 8.64 and we get 6.64. Okay, last little part here, still working with that residual plot. Residuals are really nice because they help us to see whether the model makes sense. When a linear or a regression model is appropriate, nothing interesting should be left behind. So after we fit a regression model, we usually plot the residuals in the hope of finding absolutely nothing. If there is no pattern in the residual plot, then it tells us that a linear model is appropriate. For example, you might make a residual plot and you're going to see randomly scattered plots here. We want there to be no pattern. We want the dots to look quite random. If there is a pattern, then it tells us that a linear model is not appropriate. So you have a couple options for patterns. Sometimes you're going to see stuff like this. Clearly there's a pattern there. It looks like it's making almost a parabola. Sometimes you'll see something like this. Again, clearly a pattern. Sometimes you might see something that just makes a straight line. Again, there's a pattern. This is not random. If it is not random, it means that a linear model is not appropriate. The last thing that I want to do here is show you how to make a residual plot on your calculator. So the data that we're given shows number of hours slept for one night and student scores on a test the following morning. There is a little bit of a typo here. This person did not score a 6,000% on their test. That should just be a 68. Sorry about that. So there's a few things that we want to do. We want to write an equation for the regression line. So we're going to do that using our calculator. And then we also want to create a residual plot to determine if it's even appropriate to use this linear model. So the first thing that we're going to do is type this data into our calculator. I know that the data goes horizontally, but we're going to type all of our hours into L1 and test into L2. I want to use hours slept to predict test score. So I'm going to go to Stat, Edit. I'm clearing out this other data and typing in the new data. Once we have the data typed in, we want to create a linear equation. So we're going to go to Stat, over to Calculate, and we're going to look for linear regression. You can either go down to number 4 or number 8. They will both give you a linear equation. It just switches around which you want first. Do you want the slope first, or this one will give you the y-intercept first? I usually like the slope first, so I'm going to go down to number 4. Make sure you're pulling data from your correct lists. And it's going to give you a bunch of information here. It reminds you of a linear equation, gives you a and b, which is your slope and y-intercept, and it gives you r squared, which we'll talk about in our next video, and then it gives you r, which we know is the correlation coefficient. So I am going to write this equation here, but instead of y's and x's, remember we do want to put this back in context. So our y variable was the test grade. That's predicted, so I'm putting a hat over it. I'm then going to take my a, which is in front of the x value, so that's my slope. So 2.956, I'm just going to round that to 2.96. That's right next to my x, which was hours of sleep. And then I'm adding on my y-intercept, which is 62.31. Again, if you went to Stat Calculate and you went down to number 8, notice that my a and b are now switched. That's because it's listing that y-intercept first, so you would just have this stuff and the 62.31 flip-flopped. Okay, the next thing that we want to do is actually create a residual plot to determine if it's appropriate to use a linear model or not. So to create a residual plot, we're going to edit our stat plot. This is where we make all of our graphs. So second y equals. First thing you want to do is make sure you have a scatter plot chosen. So that's this first one. My guess is right now you have L1 and L2. We want to change this L2 into residual. So I'm going to clear out what I have there, and I'm going to pull up a list, which is right above stat. So I'm pressing second, stat, going down to number 7, where it says residual. Once I have that in there, I can press zoom 9, and it gives me my residual plot. We are just going to sketch this on our paper. It does not have to be perfect, but we're just kind of getting an idea of what is going on with this residual plot. I would also make sure you label it as residual, because this is not the scatter plot of your data, this is the scatter plot of your residuals. Now we have enough to determine if it's appropriate to use this linear model by analyzing our residual plot. If you think this residual plot is random, then you can say yes, it's appropriate to use a linear model. If you think this residual plot has a pattern, you will say no, it is not appropriate. I think this is quite random. There's dots on top and on the bottom of this horizontal line. So I'm going to say the residual plot is random. So it is appropriate to use a linear model. The only thing that I do want to point out is that you can never make a residual plot without first running a linear regression on your calculator. So if I just randomly go to my stat plot and I'm like, oh, I want to make a residual plot. So I go to change this, so second stat. Notice that residual is not on that list. If you ever run across this, it's because you didn't tell your calculator to create a linear model. So you'd have to go back, do your stat, calculate linear regression first, and then create your residual plot.